Now, in the last video, we have finished example 2. Let's move on. In example 3, a composite rod having a uniform cross-sectional area consists of portions P, Q, and QR made of different materials. Now, given that the ratio of the mass of PQ to that of QR is 3:2, find the ratio of the length of PQ to that of QR so that the rod remains at equilibrium. Now let's draw a free body diagram for this rod. Now for the portion PQ, the weight of that portion MPQ, the mass of PQ times G, acts at the center of that portion. So the weight acts at the point which is at a distance which is PQ over 2 from the point Q. For the other portion QR, the weight of the portion MQR times G acts at the point which is at the distance of QR over 2 from the point Q. And we are given that the mass ratio of PQ to QR is 3:2. Now we can take moment about Q. Since the rod is at equilibrium, the sum of anti-clockwise moments equals to the sum of clockwise moments. So anti-clockwise moment is equal to the force MPQG times the moment arm, which is PQ over 2. Anti-clockwise moment is equal to the weight MQRG times the moment arm, which is QR over 2. And with that, we can multiply both sides by 2 and divide both sides by G, and we get PQ, the length, times MPQ equals to MQR times QR. And moving the terms, QR to the other side, it goes to the denominator, and that term MPQ moves to the other side, it goes to the denominator. So we have the ratio PQ to QR equals to the ratio of mass of QR to that of PQ. Putting in the given ratio, MPQ to QR is 3:2, and we get the ratio of PQ to QR equals to 3 equal to 2:3. Now example 4, about to tilt. Now a uniform plank PQ of weight 200 newtons rests on 2 trestles as shown below. It should be below. A boy stands at the end of the plank. What can the maximum weight of the boy be without tilting the plank? Assume that the weight of the plank acts through its center. I think this statement, this assumption, we don't have to make, because the plank is already uniform. Now, first thing first, let's draw the free body diagram for this plank. Now, for this type of question, often you've got to sort out the distance of different parts. Now, between trestles, the length is 3 meters, and so the 200 Newton, which acts at the center, will divide the distance between trestles into 2 equal halves. So each distance is 1.5 meters, and yeah, and we recall the reaction provided by the left threshold R1 and that provided by the right threshold R2. So when the tank is about to tilt, the reaction R1 becomes 0. Now with that, we can take moment about the support point or the right threshold, that's this point. So the sum of anti-clockwise moments equals the sum of clockwise moment. So we get for the anti-clockwise moments, W is providing the anti-clockwise moment. So it is the force W times the momentum 1. And for the clockwise moment, so I beg your pardon. So it should be the other way around. So in fact, I've done that. Okay, so W times 1 is the clockwise moment, and for the anti-clockwise moment, it is a 300 Newton times 1.2 meters, and R1 is equal to 0. You don't have to take care of it. So simplifying, we get W equal to 300 Newton. Until next movie, let's take a break.